Hey there, science explorers. Ready for a deep dive?
Always. What are we looking at today?
Today, it's a third grade science textbook. Light, shadows, sound, all that good stuff. The things that make the world so fascinating.
Oh, yeah, the stuff we kind of take for granted sometimes.
Exactly, like light. Imagine if there was no light, what would the world even be like?
Well, we wouldn't be seeing anything, that's for
And
sure.
no sunshine. Talk about a gloomy day every day.
The sun is a pretty important character in this story, wouldn't you say? I mean, it's our main source of natural light.
Our very own giant fiery light bulb way up in the sky.
And that's why we have daytime. And when it sets, well, hello darkness, my old friend.
Nap time. But hey, we're not completely in the dark even at night.
No, because we have things that make their own light. Lamps, flashlights, even those cool little fireflies.
The textbook calls those luminous objects, right?
Yeah, they're like tiny suns just radiating light.
Think about a light bulb, a candle flame, or even those glow sticks at a concert.
Oh, yeah. Those are so cool.
So that's luminous. What about, like, my desk or a pencil? We can see those, but they don't exactly have their own spotlight.
Right. Those are what the textbook calls non-luminous objects.
So they need light from somewhere else to bounce off them so we can see them.
Exactly. The light bounces off the object and into our eyes.
Like a game of light tag. Okay, but what happens when something gets in the way of that light?
Are you talking about shadows?
Shadows. Those sneaky little shapes that follow us around. Have you ever tried to catch your shadow?
Haha, many times. They appear when something blocks the light.
So picture this. You're standing outside on a sunny day.
All right, I'm there, the sun's shining. What's next?
Your body blocks the sunlight from hitting the ground, and bam, a shadow is born.
Your very own silhouette.
But have you noticed that your shadow isn't always the same size?
Oh, totally. It's like it grows and shrinks throughout the day.
In the morning and evening, when the sun's low, it stretches out super long. And then at noon, when the sun's right above, it's like it shrinks.
Like magic. But it's not magic, it's...
Science. And get this, the textbook says solar and lunar eclipses are caused by shadows too.
It's true. It's like a giant cosmic shadow puppet show.
Okay, enough about shadows. I'm ready to get a little more hands-on. Let's talk about force.
All right, let's get physical. What do you have in mind?
Well, I bet you're using force right now and don't even realize it. Go ahead, push your hand against your desk.
Okay, done. Feeling it.
That's force. The textbook says it's a push or a pull.
It's how we interact with the world, really.
Opening doors, throwing a ball, even giving a high five.
Don't forget lifting things. That definitely takes force.
Especially those heavy things. Think about how much force it takes to lift, say, a big textbook.
The heavier something is, the more force you need to lift it. It's all about overcoming that downward pull.
You mean gravity?
Gravity. It's a force that's always acting on us, pulling us toward the Earth.
Like the Earth's giving us a giant hug.
That's one way to put it.
And speaking of amazing things, let's talk about sound. It's everywhere. But what is it really?
You hear it every day. Music, laughter, the wind in the trees, all of that. It's what our ears pick up.
But where does it come from?
It all starts with vibration.
Vibration.
Like when I clap my hands, they're vibrating, moving back and forth really fast, and that's what creates the sound.
And those vibrations travel through the air to our ears.
Like tiny little waves they are. It's how our ears pick up on what's happening around us. Pretty cool, right?
Super cool. But not all sounds are created equal, are they? I mean, some are just noise.
You're right. Too much noise can be a real bummer.
It can even hurt our ears.
Which is why it's important to be mindful of the sounds we make. We got to protect our hearing, you know?
And speaking of hearing, the textbook says that bats use sound to see.
It's true. It's called echolocation.
Echo what?
Echolocation. It's like their own built-in sonar system.
Okay, explain this to me. How can they see with sound?
They send out these high-pitched sounds that we can't even hear, and then they listen for the echoes.
So it's like the sound bounces back, and they use that to create a picture in their mind.
Exactly. They can tell how far away things are, what shape they are, all kinds of things.
Wow. Talk about a superpower.
That's echolocation for you. It's like a sixth sense, almost.
It's so cool. But it makes me think, we were talking about light bouncing off objects earlier.
And how we see things because of that.
Exactly. But sound can bounce too, right?
It sure can. That's what I call an echo.
Like when you shout in a canyon and your voice comes back to you.
Exactly. Your voice, or rather the sound waves from your voice, travel through the air.
They hit those canyon walls and then bounce back.
It's like a game of sound ping pong. And the bigger the space, the longer it takes for those sound waves to travel back to your ears.
So echoes are kind of like sound shadows.
You could think of it that way. And, understanding how sound bounces and creates echoes is super important in lots of areas.
Like where?
Well, think about designing a concert hall. You want the music to sound great, right?
You wouldn't want a bunch of echoes messing things up.
Exactly. Same goes for recording studios. Now, shifting gears a bit, remember we talked about gravity being a force?
Yeah, that invisible force that keeps us grounded.
Well, it's not the only force at play. There's also friction.
Friction. Now what's that?
Imagine trying to slide a heavy box across the floor.
Ugh, I can feel the struggle already.
That's friction. It's a force that opposes motion, kind of like a resistance. The bottom of that box is rubbing against the floor, and that creates friction.
And the rougher the surface is, the more friction there is.
You got it. And smoother surfaces mean less friction. That's why it's so easy to slip and slide on ice.
So smooth surfaces, less friction. Rough surfaces, more friction. Got it. But is friction always a bad thing?
Not at all. Friction is actually super important in our everyday lives.
Really? How so?
Well, think about it. Friction is what helps us walk without slipping and falling all over the place.
Our shoes grip the ground thanks to friction.
Exactly. And it's what allows cars to brake safely.
It's kind of like a superpower, but for stopping.
Now that you mentioned superpowers, there's another force that has a kind of superpower vibe, magnetism.
Magnets. They're like magic.
Yeah.
Sticking to things without even touching them.
It's not magic, it's science. But it is pretty amazing. Magnets have this invisible force field around them.
An invisible force field.
Yeah. And this force field can either attract or repel other magnets or certain metals.
So it's like they can push or pull things without actually touching them.
Exactly. And we use the superpower in so many ways. Electric motors, speakers, and even those super fast maglev trains.
Maglev trains, what are those?
They use powerful magnets to literally float above the tracks.
Whoa, they float. No way.
It's true. This magnetic levitation eliminates the friction from wheels, allowing them to reach incredible speeds.
That's mind-blowing. Okay, so we've talked about sound bouncing and forces like friction and magnetism. What about light?
What about it?
Well, we know we see things because light bounces off them, but what about colors? Why isn't everything just black and white?
Ugh. That's where the magic of white light comes in. You see, white light, like the light from the sun, is actually a mixture of all the colors of the rainbow.
Wait, so all the colors are hiding in plain old white light?
They are. And you can actually see this if you shine a flashlight through a prism.
A prism.
It's a special piece of glass or plastic that can split white light into its different colors.
So you shine the white light in, and it comes out a rainbow.
Pretty much. Each color bends at a slightly different angle as it passes through the prism, so they spread out and you can see them individually.
Oh, like a rainbow in the sky.
Exactly. A rainbow is actually a natural prism effect.
So when sunlight hits those raindrops just right,
It gets split into all those beautiful colors.
nature's light show. So we've got white light containing all the colors and prisms splitting them up. It's like a hidden world of colors.
Right. Pretty amazing stuff.
This third grade textbook is blowing my mind.
Imagine what else we could learn if we keep digging.
Okay, so we've seen how light makes colors and how sound makes echoes. But what about all the stuff we see and touch in the world?
Oh, you're talking about materials.
Materials, right. Like my chair's made of wood, this water bottle is plastic.
And your favorite toy, what's that made of?
Something super soft and fluffy. But they
Yeah.
all feel different, right? Like wood is hard and plastic is kind of bendy.
Exactly. Each material has its own unique properties that make it behave in certain ways.
Properties. Okay, break that down for me.
Think about it. Some things are hard like rocks, others soft like a pillow.
Oh, I get it. So hardness and softness, those are properties.
Yep. And some things are bendy like a rubber band, others are stiff like cardboard.
Makes sense.
Yeah.
But what about things that sink or float? Is that a property too?
You bet. Whether something sinks or floats all comes down to its density.
Density, huh? Okay, enlighten me.
Think of it like this. Imagine a box full of marbles packed in tight. That's like a dense material. Then you've got another box, same size, but it's full of feathers, all loose and fluffy. That one's less dense.
Ah, so it's about how tightly packed the stuff inside is.
You got it. Things denser than water will sink, like a metal spoon. Things less dense will float, like a beach ball.
That explains why some bath toys sink and others bob around. So density is a pretty big deal.
It really is. Scientists and engineers need to think about density all the time, especially when they're designing things.
I can see why. You wouldn't want to build a house out of something super lightweight, would you?
Definitely not. You'd want strong, dense materials that can hold up the weight.
Like sturdy wood or bricks.
Exactly. And you wouldn't want to make a boat out of something that sinks.
Right. It needs to be less dense than water so it floats.
You nailed it.
All this talk about materials is making me look at everything differently.
Right. There's so much more to everyday objects than meets the eye. And who knows what amazing things we'll be able to create as we learn even more about materials.
Maybe some of our listeners will be future inventors.
That would be awesome. It's so important to stay curious and keep exploring, asking questions about how things work, and trying to understand the world around us.
Couldn't agree more. And that wraps up our third grade science deep dive.
We went from light and shadows to forces and materials. It's been a wild ride.
We learned a ton.
Yeah.
And who knew a third grade textbook could be so fascinating?
Sometimes the simplest things are the most amazing. So keep those scientific minds working, folks. Who knows what discoveries are waiting out there?
And until next time, keep exploring and have fun.